Hi guys, today we're going to be talking about some properties of exponential functions, and for the most part of this today it's going to be how these graphs are shifting and how they are reflected. So a lot of this stuff on here today I just copied and pasted from our book to kind of show you what it looks like. I don't necessarily have you graph and sketch all of these out. I just want you to get the gist of what happens to a graph. So I guess just pay attention as I kind of walk through and you can get the idea of what happens. So this first one, I have the graphs of y equals 2 to the x, which is in red on my screen, and then y equals 3 times 2 to the x, which is in blue. Now, your paper isn't in color unless you printed this off at home. So probably what you want to do is to write above each one of these graphs. So above the one that is red, or my red one right here, you want to write y equals 2 to the x. And then on your paper, this one, write y equals 3 times 2 to the x. So you can see the difference between those two. We talked about in last section how to graph y equals 2 to the x, and you just go to your t-table, you get some points to sketch. So what's going to happen? Oh, and let's also talk about that for a minute. Remember the y-intercept is the number that's the a value, the number that's in front of your b to the x. So my a right here is 1, and that's why I'm crossing at 0, 1. So it would make sense that on this graph, my y-intercept, I'm crossing at 0, 3, and that's why my y-intercept is right here. So if you can identify the y-intercepts on graphs, you can kind of determine pretty quickly if it's going to be a skinnier graph or a graph that's closer to the y-axis, or if it's going to be a fatter graph, a graph that maybe comes out this way and is closer to the x-axis. Keep in mind it doesn't matter. The x-axis is still going to be an asymptote, so it's going to get really, really close to it, but it's never going to touch it. All right, let's take a look at my next one here. I have y equals 3 to the x, which we graphed in the last section. Y equals 3 to the x, the y-intercept is going to be 1, so that's why I have a 0, 1 right there I'm hitting. And then again on this one, you might want to put or draw on your graph because they're not in color. This is the graph of y equals 3 to the x, and this is the graph of y equals negative 1/3, 3 to the x. So it's kind of interesting because on this one you can see that the negative sign, the number in front, just like a parabola, it reflects it over the x-axis. It flips it over. That's what the negative sign does. And if I'm looking for the y-intercept, this is my y-intercept, 0, negative 1/3. And you can see I'm crossing at 0, negative 1/3. Okay, let's take a look at our next one. The next one I have here is on the second page of your notes. And it's the graph of 2 to the x, and then something a little bit different. Sorry, this one is the graph of 2 to the x, and then 2 to the x minus 4. So something that they're doing to that exponent there, and watch what it does to the graph. I wrote above this one, y equals 2 to the x, and then above this one over here is y equals 2 to the x minus 4. You can see on this one that when I have this, the blue graph is actually just shifted over 4 units to the right. Notice they just took this point right here and went 1, 2, 3, 4. They took this point on y equals 2 to the x and moved it 1, 2, 3, 4. Every point was just moved over 4 units to the right. So what happens when you have something in the exponent in those parentheses? Remember when we were doing parentheses like on y equals x minus 2 squared plus 6? This number moved it up or down, that would move up, and then this number you always had to think opposite. So we knew it was a parabola, but it was going to move it 2 units to the right. The same thing applies here with this in the exponent, that if it's a negative 4, it's going to move 4 units to the right. It's opposite of what you think it's going to be. The next part of your notes just kind of explains or gives you a little scenario of what happens when for each one of these, a little summary. So if this is my parent function, which would be my y equals 2 to the x or 3 to the x or some of those easy ones we've been graphing, if the a value is bigger than 1, it stretches it. It makes it, remember how we talked about yoga and you stretch, you get skinnier, so it kind of makes it closer to the y-axis. If that number is between 0 and 1, if it's a fraction, fractions make you fatter, it's going to get wider. It's going to get closer to the x-axis. So instead of looking like I'll draw it in black. It's going to go, this is like, let's say your normal one. A fraction one is going to look like that. It's going to make you fatter. You might want to make yourself a little note over here. Fractions make you fatter. And then I like that they put this little reflection one in here because that shows you that if that first value a is a negative number, it gets flipped over the x-axis. And then the last one here, this translation, it kind of tells you what happens if you have something in the exponent, it explains it shifts it horizontally, that's left to right. And if there's a number behind it, like this, it's going to shift it up or down. Now that's interesting because when you start shifting stuff up and down, you're going to have different kinds of asymptotes. It might not always be the x-axis, or it might be like a line, like y equals 4 might be an asymptote. So we'll talk about that a little bit more. And then this last one here, they kind of put everything together. It has all transformations combined. They made it skinny or fatter depending on what a is. They moved him left or right, and then they moved him up and down. Now, what I'd like you to do in this next 4 problems is maybe stop the video and see if you can answer these 4 questions before I go over them. The question is, describe the transformation in each figure. Is it a stretch, a compression, a reflection, or a translation? Now here's the thing. A translation, another word for translation is slide. A slide is a stretch, and a slide is a compression. So you don't have to tell me the word translation in these or on homework. You can just tell me whether it's a stretch or compression. The one I'm going to start with is this one, the second one here, because that's the easiest one. You can tell he got flipped over the x-axis, so that one is a reflection. Now, the black solid lines are the original graph. The dotted lines is how it got moved. Okay, so if this is my original and this is my new one, can you tell he is skinnier? He got closer to that y-axis. So on this one, I'm going to say I have a stretch. He was stretching like you do in yoga, and he got skinnier. Whereas this one over here, this is my new one, he definitely got fatter or wider, so he's called a compression. And this one also is wider, so that one is called a compression. So just be able to identify the difference between a stretch, skinnier, and compression, fatter. The reflection, I think, is the easiest one to identify because it's just flipped over the x-axis. All right, the next page of your notes talks about the number e. Now, just like we have the symbol pi, pi represents 3.14, the number e, it sounds weird because you're saying the number and it's a letter, this e represents a number. If you go to your graphing calculator and you go to your run menu here, and you can see that above this, it looks like an IN, but it's really LN, stands for natural log. We'll talk about that in this chapter too. Above this button is e to the x. And that e, just like this pi button down here, if I put in shift and then pi, it tells me it's 3.14. Well, if I want to know what e is, what happens is e is always raised to a power. It's always an exponential. So when you type in this e, you have to push shift and then your e to the x. It automatically brings up a caret key. Well, if we just want to know what e is, that's the same thing as e to the first power. And when I hit enter, e is represented by the number 2.718281828, but I'm going to abbreviate it to 2.72. Always round to the hundredth spot for me. So even before we get started on this, I want you to write e equals 2.72. So if I want to evaluate these other numbers here, it's really simple. You put in the value of e, you go shift and then ln, and then you have to put, now don't do this, don't give it a baby 2. It assumes that when you type in the e, that the next number is going to be an exponent. So if I type in a squared, I just type in a 2 because that means e squared, and I get 7.39. So that's what I'm going to put in for e squared is going to be 7.39. To e to the negative 2.5, same idea, real simple. You just type it in, shift ln, and e to the negative 2.5. and it's 0.08. Very, very simple. Okay, the last part of our notes here is about continuously compounded interest. A little bit different formula than what we talked about in 7.1, but very simple. You just need to understand what each of these represents. This represents the total amount, that's just the account at a certain time. So this is like total. Principal means how much did you put in the account, what did you start. Interest rate is your R, time is your little t, and E, you never are going to fill in a number for E. E is that button that's on your calculator. That is that 2.71. All right, so the question says, find the amount in a continuously compounded account for the given condition. So I put in $5,000. So my total amount is going to be my principal, $5,000, times E, and then my rate is 6.9%, which is really 0.069, and then times 30 years. So the question is, if I put $5,000 in an account that's compounded continuously for 30 years at this rate, how much will I have at the end of 30 years? When you enter this in your calculator, you want to type it in like this. You're going to go 5,000, and then you can put in E, and then parenthesis, 0.069 times 30. And then if you hit enter, it's 39,624. So I'm going to write this here, and then we're going to try one more. See if maybe you can do this next one on your own, then come back in and check and see if you got it right. So the last one here, I have a principal of $20,000, so I'm going to start with that one. Remember, my total account is T, total amount in my account. There's your $20,000. E, and then 0.0375 times 2 years. See if you can enter this in your calculator correctly. And my final answer is going to be, I have $21,557.68.